Well, let's real quick work through an example for format. So you can see how this works. This is going to be page 1 of, I don't know, probably 1 of 1. So you can kind of see how I would like you to structure these homework problems. We're going to work this fundamental problem 3.1 right here. And so you can pause it if you need to copy that down. But if you've got your book, you can just pull that from 3.1. That's the 14th edition of Hibbler. And I'm going to work through this problem right here. So you don't have to copy it down exactly verbatim. This is 3.1. This is fundamental 3.1. And so you've got, it doesn't have to be perfect and pretty, but you want to kind of roughly draw how they've got it in the book. So you've got a cable, you've got some sort of a knot or structure there, you've got another cable going up, and you've got attachments to the wall. You've got a wall here and a wall there. They've labeled these points A, B, and C. And then there's another cable hanging straight down. We call this connection point D. And there's a box here. Now this is chapter 3. If you're watching this early, it's okay if you don't know all the theory behind this yet. I just want you to see kind of how I set a problem up and how it looks. So you want to put all your information from the text on your diagram here. This is a 30-degree angle here. This cable is defined by a 3, 4, 5 triangle. So 3, 4, and a 5. And again, we'll get through all the theory of what all that means as we get further along. But I want you to see kind of how to set up a problem. That's our goal here. So you can see that's what we have here. They've said the crate is 550 pounds. Okay. Well, and then all I ask you to do is to write what is it that you're trying to find. You're trying to find the force in each cable. Right, so make sure that's clear somewhere in your problem, because the goal here is you want to have something that you can go back and study later. So if you can't figure out what it is you're looking for, it's going to be hard when you go back after a couple of weeks when you're studying for an exam or studying for the final after a month or so. What was I trying to do with this problem? Your homework really should be a really good study tool for you to go back and say, oh, how did this problem work? How did I do one of these problems? We've already mentioned practice solving problems. That's really the whole goal here. Now, the whole idea, what you really want to be able to do, problem solving, is, basically, if we talk about basic problem solving, what are you looking for? Number 1. Number 2, what is known? Number 3, what laws or equations? I write in cursive, I'm sorry. I write terribly on top of that. What laws or equations or tools are useful? Step 4 is a question. Well, they're all questions, aren't they? Step 4 says, do you have everything you need? Right? And basically it is, do you have as many equations as unknowns? Right? Do you have as many equations as unknowns? If the answer is no, you go back. Now you have unknowns. Okay, so those become what you're looking for. What do you know about those unknowns? What tools, laws, or equations do you have to find those unknowns? Do you, once you've written all these down, do you now have enough equations to find all of the unknowns that you need? Do you have as many equations as unknowns? If the answer is no, you go back and you repeat. And this is how basic problem solving works. When you hit the point where the answer is yes, then is step 5, the final step. Just go do the darn thing. Just go solve. That's the only one that's not a question. You don't complain about the amount of algebra. You don't complain about how difficult it is. You don't complain how much work you had to do to get there. That's not what engineers do. If that's what you want to do, then there are plenty of other majors you can go pick from. This is what we do. Engineering is the application of science and existing knowledge to try to solve problems. This is how we solve problems. If you learn nothing else from this course, this is really what we're trying to teach you. You're going to learn statics along the way. At least that's the hope. But this is really what we're after. And I'm probably going to point back to this multiple times throughout the semester. I'm going to set it right over here so I can keep that. Let's look at this particular problem. All right. So what we figured out what we're looking for. Right. What we're looking for is we're trying to find tension AB, tension AC, and tension AD. That's what we're after. So how do we find that? Well, right, what is known? What is known? Well, what we do know is I've got 550 pounds here. That's about it. And I do know the geometry on these guys. And I also know that this thing is going to be in equilibrium. What does that mean by equilibrium? It means if I add up all the forces, those forces are going to add up to be 0. So what I can do is I can say, well, if I'm to draw and in statics, it's all about free body diagrams. What am I drawing a free body diagram of, though? Well, if I draw a free body diagram of the crate, right? So a free body diagram is simply where you draw a rough image of the object and you draw all the forces acting on that object. I've got 550 pounds weight acting down, and going up, I've got a cable here. Anytime I've got a cable on a free body diagram, I replace that with a tension force. This is tension AD, because a cable can only hold tension. Well, if I add up then all the sum of forces in the x direction, that's equal to 0. Well, there are no forces in the x direction here, so nothing to add. Sum of forces in the y direction being 0. What do I have? I've got tension AD minus 550 pounds. And I can solve this, right? So we ignore this at this point. This is my equation. I've got one equation, one unknown, and we solve that, and that's easy. Don't need a calculator for this. TAD is equal to 550 pounds. Okay? And then from there we go. Is that everything? Did I find everything? Well, I'm looking for these 3 tensions. And you can't read this very good. I apologize. AB. That's a little better. I've got this one. Found it. What am I looking for now? Well, because that's the process, right? Do I have as many equations as unknowns? Well, I'd solve for one, but I've still got 2 unknowns. So what am I looking for now? So what is known about TAB and TAC? Well, I know they're attached to this knot right here. So what laws, equations, or rules, or tools can I apply to this knot right here? A, well, I can draw a free body diagram, just like I did here. I can draw a free body diagram and apply Newton's first law of knot A. And so if I do that, knot A, so I've got if you look at what's attached to knot A, I've got a cable here, and a cable here, and a cable there. I've got 3 cables, so I'm going to draw tension forces at all those. I've got TAD pulling down, because it's tension. Tension always pulls. Now I'm going to draw in components here. I've got TAC, and I'm going to draw the x component of TAC. It's going to be 4/5 TAC. Again, if you're watching this ahead and you have no idea how I got there, watch the other videos as they come, and we'll talk about how I get there. In the y direction, I've got a y component for TAC. That's going to be 3/5 3/5 TAC. And then on AB here, in the up direction, I've got AB, and it's the sine of 30. TAB sine 30 degrees. And the negative x direction, I've got TAB, and this side is adjacent to that 30 degrees, so that's going to be cosine 30 degrees. And this is my free body diagram. What does that do? Well, that allows me then to add up my forces. Sum of forces in the x direction, I'm going to have in the positive x direction, I've got 4/5 TAC. In the negative x direction, I've got minus TAB cosine 30 degrees. And those are going to add up to 0. So one equation, two unknowns. I don't know either of these. I can find this. I know this. It's equal to 0. So one equation, two unknowns. I can't solve that. So what do? I write another equation. Sum of forces in the y direction. That's also equal to 0. In the y direction, I've got TAB. This one is sine 30 degrees. Also in the positive y direction, I've got 3/5 TAC. And the negative y direction, I've got minus TAD. So I've got two equations here. This one's unknown, this one's unknown. Same thing here and here. This is another variable, but remember I've already found him. So I've got two equations, two unknowns. Remember our process. What are you looking for? We've already defined that. We know we know what's known. We've got some tools. We have as many equations as we have unknowns. Go solve. All right. I'm going to pause here so this doesn't get too long. I'm going to do the calculations. All right. So I've gone through and done the calculations. I want to show a few things here. I've boxed in my answers so they're clear and easy to find. I've gone through the calculations. I had two equations, two unknowns. Solve for one of them in terms of the other one. However you do your algebra to get from these two equations with two unknowns, AC and AB, how you get two answers, I'm really not too picky. As long as you do your algebra right, you don't break any rules. Three significant figures. Right? That's just a general rule in engineering. Three significant figures. You can do more if you have a good reason to, but there's really very rarely is there a good reason to. Whatever they tell you in your science and your chemistry classes and your physics classes, whatever they tell you in your laboratories to do with significant figures, do those there. Here, three significant figures is plenty unless we've got a really good reason to change that. But you can see your answers. Pause it here, and so you can see all the detail. Again, just a very clear path, because inevitably you're going to make a mistake. If you're in the habit of showing me how you get, right, how did you go through this process? You don't have to write this process out, but if your work clearly shows how you got from this process, then when you do make a mistake, it's easier for me to grade. And if you're in the habit of doing it on the homework, then when you actually do it on the exam and you make a mistake there, it's so much easier for me to grade there. Anyway, let me know what questions you have here. Hopefully this helps.